What's up, George? Oh, I forgot how to find the lectures. Studying physics in it? Yeah. I can't find the lecture though. Two plus hours? First law of thermodynamics. Yeah, it says the homework assignment's gonna take 2+ hours. What's up, Raghad? Let me pin. That's short? No, that's long for a homework assignment, dude. There's no homework assignment that should be longer than that. Does that invite even work still? Yeah, that does. What's up, HC? Next year during my gap year, I'm gonna learn A-level maths to help for when I go to uni. That's a great idea. Stop. Bro, this cat, bro, what's up with him? Bro, the lessons are supposed to be on talent, or the lectures. No. That's not real. That's not real. Don't you guys worry. I don't have that low of a grade in the class. Oh my gosh, this cat, bro. What's up, Ollie? Off my keyboard, dude. Oh, lecture videos. I'm an idiot. Stop scratching my the kinetic theory of gases. Bro, why does this? Bro, come on. Okay, you gotta get off my keyboard, dude. Oh, my bad. I didn't mean to. He jumped. But you guys should see, like, he's literally laying on my keyboard. Like, I'm trying to do work and he's just laying on my keyboard. Just pressing all sorts of keys and jumping on my mouse and shit. I'm about to eat. I got so much food from Jimmy John's. Yeah, the other cat doesn't interact with humans. Yeah, I try not to study at night. My other cat is like, I don't know. It has no regard, like it doesn't even care that, like, if you're anywhere near it. It'll just like walk away from you, no care in the world. Like you'll pet it and it's just like, it just ignores you. It's like it doesn't have any feelings. Where are you studying? Like what university? To use a lint roller on my mouse pad now, because this is ridiculous. Good morning. It's not morning here, but good morning. Illinois. I go to University of Illinois, Urbana-Champaign. What's your major? Physics. Now these guys want to be annoying too. Flip my dry cleaning something. What's the most doable if you're bad at math? There's tons of majors for people who are bad at math. I mean, I don't know if you're truly bad at math or if you've just not been exposed to a math that you've been good at yet, which is an interesting kind of paradox. It's like, are you really bad at math? Oh my gosh. Like, are you really bad at math, or is it just like you haven't? Okay. You're okay at math? Yeah, you're probably good at math. I wonder if there's a math class that you haven't been taught yet that you would actually be really good at. So that could be, you could be just not good at the math that you've been learning or not interested. But you can be a lawyer, doctor, there's plenty of things. Literally like every major besides like anything engineering doesn't have math. Yeah, being a doctor is extraordinarily difficult. Okay, wait, I actually think something pretty important is here. Okay, I think this is one of the never alone shipments. I need a knife or something. Okay. Wonder which shipment this is. It's about damn time, bro. Manufacturer's been slacking. Almost taking what took them so long. Okay. I think this is okay. So there was an issue, with the clothes. Like the manufacturer ran out of like a certain type of sweatshirt, like the main sweatshirt that I sell, and so they sent me some of these like lower quality sweatshirts, but still the same design. And I think these are the lower quality ones. Yeah, just looking at them, they look like they are. Never mind. They're not. These are the good ones. Okay, so this is a small size, I think. Okay, let's see if they did a good job. Okay, the print is good. Print's pretty good. Print on the hood looks good. I need to wash these. I need to stress test them to see if like this stuff's gonna come off in the wash or not. If it comes off in the wash, then it's not really that big of a deal. I'll just on the website I'll put wash instructions. It shouldn't though, because it's supposed to be high quality, right? Like it shouldn't come off in the wash, but it's not really that big of a deal if it does. Okay. So these are all. Okay. Oh, so this is the other shipment. Okay, and this is one of the new designs. You probably can't see because you can see it on the camera. It's black on black, but it's like velvety. It's hard to explain. Let's check. Yeah, it's still the same inside. Huh, I wonder what's different about the... apparently these are the lower quality sweatshirts, but they feel like they're really good quality still. The stitching's nice. Look, this is what the inside is like a suede. Like the inside's like suede. I don't know how to explain it. I don't think the camera can really like pick it up, but the inside's like suede, not like standard cotton. Oh, I forgot I put this on the back. Yeah, so that's pretty cool. The first shipment came in. I think this is only like $500 worth of this stuff, so not even like an eighth of it. Not even like an eighth of the clothes are here yet. Dude, I was actually kind of mad because she texted me and she was like, yeah, we're missing $500 worth of clothes. And I was just like, what do you mean you're missing it? And then she was like, oh, we can send you some different sweatshirts and we'll send them like, so the shipping, like thousands of dollars to ship from China. And they paid for like express shipping. So it got here before like the main shipment, even though it came like, they sent it out like a week later. But so these are supposed to be lower quality. I mean, I'm so confused here. Do they have WhatsApp for, what am I doing? I'm gonna open that. Let me open Flatpak. Is there WhatsApp for Ubuntu? Unofficial WhatsApp, unofficial WhatsApp. No, there's WhatsApp clients. Are those trees on your whiteboard? Yeah, it's regression. The regression trees. Whatever. I don't need it actually to be no, I just go to WhatsApp. You can just use it through the web. It's not really that big of a deal. Oh. Download WhatsApp web. What the fuck is this? Okay. Any tips for studying for standardized tests? Bro, just do a bunch of practice ones. Like the old year's exams, just spam those. You'll realize, like, if you just spam the past exams and you do like a bunch of them, I'm talking like at least 10 years of exams, multiple versions from each year, you'll realize they reuse the same questions. They might word it like a tad differently, but they reuse the same questions. And when you take like the real exam, you'll be like, bro, this is a joke. Like, I've literally answered this question before already. That's like the best feeling in the world too. It's like when you sit down for an exam and you're like, holy shit, like I've done this exact question before. I know the answer. It's super free. And then like the whole exam will be like that, and then you're chilling and you'll get 100. Okay, I don't know how to sign in here. Settings, tap link to devices. Oh, here, link devices, link device. Bet. Alright, bet. The C has arrived and it will be delivered on Friday if it is fast, and Monday if it is slow. Yeah. Wednesday. Okay, so the real shipment won't be here till Wednesday, May 29th. This is like all the clothes. Wait, can it tell me like how heavy it is? 44 pounds. 44 pounds of sweatshirts. How much is one sweatshirt? One sweatshirt's 850 grams. 850 GSM. That's what it is. To pounds. I think it's 850 GSM. Grams per square meter of paper. No, clothes. Ounce per yard squared? What? Okay, well, they don't even have it here. Weight converter, here we go. GSM, 850 GSM. So about 1.25 kilo. No, that's too heavy. 1.275 kg. That's too heavy. It's not. It's 44 pounds. What was the one that just came? Oh, I could just look at the box and find the thing. How did you start running your company never alone? I started in high school with my roommate named Langdon Rogers. Yeah, me and him. That's really. Didn't you have an exam recently? Yeah, I had an exam yesterday. I got an 80 on it, so I'm not very happy about that. But I didn't study that much. If you like watch the stream where I say like studying for physics exam tomorrow, if you watch the stream, I didn't study for physics 1 single second. I was doing the Discord and some website development and stuff, so it was my fault. But at least I know now that like I can just walk into the exam and get an 80 without studying. So like when I actually study next week for my exam, I'll actually be able to get a good score. Why do you ignore my questions and answer other ones? It's that I'm really late, so I'm just trying to read like from previous chats. Always a good day when Aiden streams. Thank you, bro. I swear it patterns when I think about it. Everything is a pattern. Oh yeah, facts. Real shit. Higher level classes usually don't have past exams, at least in physics. I think that's well, at least in my experience, that's completely not true. All of my higher level classes have past exams online that I can find. Most of the classes give you the past exams as well. Yeah. So that's not been my experience. What operating system are you using? I'm using Linux. Can you answer my previous questions, please? What did you say? How did you start running your company never alone? I answered that. What can I do to fix my sleep schedule? I usually go to sleep at 1 a.m. That's crazy. And I wake up at like 8. I want to wake up at 6 to 7-ish like you do to get a productive day. I honestly think your sleep schedule is not too bad. You definitely shouldn't go to bed at 1 a.m. I would say the main thing to do is like don't use screens right when you go to bed and when you wake up. That's what I do. I have a Google Home, so I just ask Google Home to give me like a bedtime story, and I do that instead of, because I used to watch like Hulu or whatever before I would go to bed, or YouTube. And so I just had Google tell me a bedtime story, and it's like the same stimulation but without the screen. So it helps me go to bed because the screen suppresses melatonin. Even if you have your phone on night shift and minimum brightness, it still suppresses your melatonin. They actually did a study on it. I just read the research paper about it. So what is it, Google Home? It's just like a thing you plug into the outlet. Bedtime story is crazy. Yeah, no, I listen to like Cinderella sometimes. Like it's random. I just tell it to give me a bedtime story. It gives me like Cinderella or like Beauty and the Beast. I've listened to like every story you could possibly think of. They're great though. It really does help me go to sleep. Yeah, but no screens, especially phones. I mean, TV is not that bad because it's so far away from your face. So a lot of the light gets dispersed and it's not that damaging, but still any screens to any capacity is not good. It should be like pitch black when you sleep. That's what your brain wants. Like that's what is ideal. What about PC before bed? Yeah, PC is even worse than phone, arguably, depending on how far you have your monitors away from your face. But yeah, no screens. So when you wake up though, if you can, try to get like as much light as possible, as much natural light as possible right when you wake up, and that'll help you like get started for the day and help you out a little bit. But before you go to bed, do not use any screens. That's the main thing that I did. When I used to be on like my rigid sleep schedule, I had like a specific schedule of what I would do. I would read a book and drink a cup of like chamomile tea, and then I would go to bed. And like I noticed that once you like get these patterns, it's like when you do certain things, your brain will immediately like start to fall asleep. Like now when I do my nighttime routine, when I wash my face and put on, well, I don't have cornrows anymore, but when I put on my do-rag, I would like literally start falling asleep the second I started doing that stuff. And so like I could fall asleep a lot easier because I had like patterns that my brain recognized and start producing more melatonin because I was doing those things. I should leave my home to get sunlight. Yeah, you can do that. I just open my window, or turn on the lights in your room, like immediately turn on all the lights in your room, and it forces your brain to like kind of wake up a little bit. Definitely no phone use when you wake up. And one huge thing actually that like changed a lot about my day is me using my phone in the bathroom. I used to like my morning routine, showering, washing my body, washing my hair, doing my face care and brushing my teeth, all that stuff would take forever. It would take I would have to wake up like an hour before everything. And now I don't bring my phone in the bathroom. I don't even go on my phone. Like I have my alarm set. It's my phone, first of all, I have it charging like really far away from me, so I can't even go on it if I wanted to. I have to get out of bed to turn off my alarm, and then I go to the bathroom and I don't have my phone in there. My shower's much quicker, much faster, and I just feel a lot better after after I'm done, because I didn't use my phone. The phone just slows everything down, and the slower you are in the morning, the slower you are going to be throughout the entire day, and the more tired you're going to be. Because like fast pace is what wakes you up. High stress, high alertness is what actually wakes you up, like biologically. What distro are you using? I'm using Ubuntu. Also, is wearing special glasses affect anything while watching my PC before bed? I would recommend not watching your PC before bed. I try to get off my PC about 3 to 4 hours before I go to bed. Stop, dude. I gotta sell this stuff. Yeah, these are blue light glasses actually, but they're a little bit more than that. They're computer glasses, and it's so that my eyes don't get damaged over time because I sit in front of a screen for so long. But no matter what, when it's nighttime, looking at a screen is dangerous for your sleep schedule. Like no matter what you do, you can wear glasses, night shift, brightness, doesn't matter. It's still damaging for your circadian rhythm and your sleep schedule. Because like you gotta think your brain is like literally, it's like you have like a caveman brain. All your brain wants to do is wake up when the sun rises and go to bed when the sun goes down. So as long as you can follow that, then you'll be able to sleep pretty well, and you'll have a better sleep schedule. But the phone, it like mimics the sun, and you're like that's how your brain interprets it. So it's really dangerous. Since now I ain't gonna watch PC. Yeah, that's good. That's good. Yeah, you need to get a lot of sleep if you want to grow. If you had a normal high school test and wanted to get a high grade, how many days before would you start studying, and how many hours would you study each day? So I would probably I study a lot, but that's just like repetition. I would say the main thing is like learn the concepts early. So when you're doing the homeworks or reviewing lecture notes or something, learn the concepts like weeks before the exam, and then you can kind of just slack off for a while until like I would probably study like 5 days before the exam, and then you just start reviewing everything, and then it'll start clicking, and then 3 days before the exam I just grind practice problems, and then the day of exam, I usually walk into the exam and I know exactly how to answer each question, because it's either something I've seen before or I learned the concept so long ago and studying ingrained it into my brain, so now I can just easily interpret the question and answer it. But yeah, I think the main thing for getting good grades is when you're doing like the homework assignments or anything, discussions, anything in class or anywhere, actually try and do it like to your full capacity and make sure you learn at that point. Because when you study, you should never be learning something. Like honestly, you should never be learning something completely new. You should just be like practicing something that you either already knew or you're currently like trying to learn better. And you might like learn new things, or I was doing this wrong, my method was wrong, but you shouldn't be learning concepts when you're studying. Otherwise you're just probably not going to get a good score on the exam, because you're going to be crushed for time. It's very difficult to learn concepts in a short period of time, but it's very easy to drill home practice problems and just do a whole bunch of repetition things that like drill it into your brain. It's very easy to do and will help you a lot. So now it's 11:08 here. I'm watching Aiden Andrews. Tomorrow at 9:30, I have a physics tutor. If I go to sleep at 12, then wake up at around 7. Yeah, it's 7 hours of sleep. That's decent. And the next day, because I'm tired, I'll automatically go to sleep earlier. No, I don't know what. I don't think. Like if you don't get enough sleep one night, it won't make you go to bed earlier the next night. It's not really like how your brain works. It's just gonna make you tired in the morning, and then it just takes longer for your brain to wake up. What you sleep, your sleep is completely independent. Like every single night, your sleep's completely independent. Like last night, I could have gotten 4 hours of sleep. The only thing that would have done was made me tired when I woke up this morning, and then I would obviously, like, I have stuff to do, so I had to persevere through that. I would maybe take a nap during the day, which would be terrible for my sleep schedule, and then I would be really awake by the time I would like to go to sleep. So it's just gonna delay everything. It's not actually gonna make you tired earlier the next day. It's just gonna delay the rate at which you like get alert and get energy, and then I'm gonna end up sleeping even later the next night. So it's just like that's why it snowballs. That's why people's sleep schedules get so messed up. It's because it snowballs on top of each other. It's like if I don't get enough sleep one night, the next night I will get even less sleep most likely, and then the next night I'll get even less sleep, and then maybe Saturday I'll sleep all day, but then that's just gonna ruin your sleep schedule. And do you know about yoga? I used to do yoga like a long time ago, a couple of years ago. I haven't done yoga in a very long time. I would like to do it. It's very good and healthy, but I don't do it. My sleep has been cooked for a while. I'm probably never at my full potential when it comes to education. I'm literally always tired. Yeah, exactly. I bet if you fix your sleep schedule, you'd notice a lot of things become a lot easier. But why when I wake up at 7 to 8, I'm very tired and unenergetic, though I got like 7 hours of sleep? That just is because of it's either because you're not getting quality sleep, which screen time really will help the quality of your sleep, maybe some medications, but it's not all about quantity. You need to have quality sleep, and when you wake up, you need to have a quality routine to get you out of like the sleep state that you're in, because you don't just wake up with energy. It's not possible. You wake up and you do like the things you do in the morning, and that's what gives you the energy to go through the day. So I would say get like a morning routine and try to get better sleep. Do you think it's fun to look up concepts? Yeah, of course, dude. ChatGPT is amazing. Try to find them. I read the textbook first, but if I need help, I use ChatGPT. ChatGPT is very good at teaching. I usually study the night before exams during my first year. Bad idea. I realize how optimized you are with full sleep and not cramming. Yes, cramming sucks. I end up not having to cram. Like when you watch me, when I do my streams, when I study, it's very like calm. Like I'm not really like high alert. Like I don't have to study. Like I never have to study. Like it's always just, I'm studying more just to get a better grade on the exam. So when I study, it's very calm and relaxed, and I can kind of do it at my own pace. And nothing's forced. That's my brother back there. They said you were staring at them. I'm doing decent in school, but I'll try fixing my sleep schedule. Yeah, I mean, that might help a little bit. It should. 44 pounds. Okay, wait, I need to see how much the shipment was today. Yo, you see this? This is some of the sweatshirts. You want one? Yeah. Here, these are the two.
I'll wear it to the gym right now.
What? That's, I think it's going to be too small for you.
It's not the same?
It is. Well, it's not, actually.
Oh, shit. Yeah, this one's different. I'll wear this one.
It's going to be too small, I think.
Yeah, Jimmy John, you should have told me you could get a discount.
Oh, because you worked there?
This one.
It's too small.
What's that?
I have bigger sizes.
That's cool.
What?
Look, can't.
What is it? Yeah, it's so stupid. I saw that. Okay, this shipment was 10.6 kilograms. 23 pounds. So it's double. It's double this, and this has about. I don't even know how many sweatshirts are in here. Wait, I actually don't think any of these are. Or I don't think any of these are larger size. Actually, these are all larger. Yeah, the larger sizes are still in the mail. Good night, Ollie, bro. Good night. Hope you fix your sleep schedule, bro. He's somewhere else in the world. I think he's in Alberzekistan or something. He said. I remember he said it one time. Something. Some country. I've never.
This on team.
Azerbaijan. Azerbaijan. You know what that is? What is that? You bought that entire contraption on Temu?
It's like $2. It's an air pump. Like for your tires.
That shit's not gonna be good.
It's better than not having anything. You can get a flat. That's all. That's the top button is on. So you adjust what you wanted.
You should have just got one on Amazon.
Then I got like this.
Look, I have one in my backpack.
I got some stuff in my interior. Yeah, but it's cheaper.
What?
It was $2.
Yeah, but it's shitty and it's not gonna work.
It's the same one. You have one. I think I saw it in the garage.
No, I have this one. It's tiny and it works really well. I can fill up my car tires with this.
Yeah, that's what this is for. It's $2.
This was $40 and it works.
This works too. It's $2 fucking, dude.
Bro, you realize you just funded like complete
$2.
you just funded slavery. You just funded a company that takes advantage of its employees. I hate Temu. I hate Temu with a passion. I don't hate many things in life. Right to Turkey, that's sick. I'm going to Turkey this summer actually. Is there a way to make my PC not be able to turn off after a certain time at night to prevent blue light? Not be able to turn off? Like I won't. Oh. I don't know. I don't think so. You'd have to Google that. I have no idea. I've never like done anything like that. I don't know. Temu is where the line is drawn. Yeah, Temu is terrible. What was your GPA in high school? When I applied to college, my GPA was a 4.8. When I submitted my applications. See you later, bro. See you later, Ollie. When I graduated, it was not a 4.8 though, because I had what they call senioritis, where you don't go to school in your last quarter of senior year. Not only did I not go to school, I didn't do homework. I just didn't do anything. Just think about all the stuff that you have to do for school and just realize I didn't do any of it the entire last quarter of senior year. Because I already gotten accepted into school. Like, I wasn't gonna start trying now. Like, I wasn't gonna continue to try. How does your applications work? I'm pretty sure it's the same. It's the same. It's the same. It's just you apply. We have like 5 choices to pick from. Yeah, I only applied to 2 schools, so I only had 2 options. But it ended up only being 1 option because I didn't get into the other school I applied. I got waitlisted. Today was your last day of school? That's sick, dude. The other school I applied to was Harvard. Yeah, Harvard and University of Illinois. Okay. I'm eating. I was an athlete at the time, so I didn't really care. I was planning on playing juniors for hockey, but I got injured, so it forced me to go to college. See you later, bro. Good luck in your studying and good luck on your exam. Thanks, Vaprium. Appreciate it. Thank you, bro. Yeah, I took my braids out. They were getting too frizzy. From 2024 to 1980. It's funny. I'm eating Jimmy John's. Alright, let's watch this lecture. Where's my paper? Ask me something hard, dude. I don't know what to ask you, dude. The kinematic theory of ideal gases. Let's do this shit. Let's do this shit. We're gonna have to change camera angles for this one, buddy. What's new for Apple Pencil? I don't know, gang. Oh, what app was that? ChatGPT app? ChatGPT app got update or something. New voice mode coming soon. We plan to launch a new voice mode with ChatGPT within ChatGPT Plus in the coming weeks. We'll let you know when you have access. Watch the demo. Yeah, I want that app, bro. That's what I was looking for, dude. Yeah, shut up, ChatGPT. Don't talk to me, boy. Don't talk to me, boy. Damn, physics 2 is easy. On God, it is, Rob. Yo, Rob, are you in the Discord? I need to make you a mod. You're in the cord. Alright, bro. What's your at, dude? How do I see numbers? Oh, there it is. What's your at? What's your name? Let's just look up Rob. Let's see if he comes up. I don't know. I don't really know how to use Discord. Nasty Rob. All right, bet. Or you're in the channel. All right, bet. That's much easier. Mod. All right, there you go. You should be a mod, bro. I think we hit 100 members maybe in the server. I don't know. 22 plus 77 is 99. Including me, we're at 100. Including me, we're at 100, but technically, like, cause I don't count. Oh, and ChatGPT is in the server. So we don't have 100. We're at 90 something. Like 95, because I can't include bots either. We're at 95, bro. Bro, this cat. Look at it, bro. This is my mouse, buddy. What's wrong with you? What's wrong with you, boy? Alright. I was gonna do camera setup. Oh yeah. I gotta do the locked in camera setup. I gotta do the locked in camera angle. I need to buy a new camera, another camera. I actually think I have a camera. I have to buy an Elgato though for it. to be able to use it on my computer, or like to be able to use it with OBS. It's kind of rebooted. Alright, let's get logged in, gang. Alright, bad. Cat, kitty, cat, cat, kitty, cat, cat. You gotta get out the fucking way, dude. What page did we leave on? This is all I have to do for physics today, and then I'm done. Seems like it's about. It should take about, I don't know. So, 41 minutes. We got through a lot of that today. Oh, I forgot you can't just skip to the end. Oh, and I need to put my headphones on. Oh, I think they're fucking dead, dude. Can we see where he ends, bro? He ends on this page. Wait, hey, this is the page we ended on in class. Or we already went over that page in class. I think. Yeah. Oh, I've already done this, so I gotta go to lecture 4, dude. Yo, what's going on? Introduction to Thermodynamics. Oh yeah, this is where we were. Yeah, we already went past this though. So I gotta watch this lecture. But bro! Wait, I just want to see what page we're gonna end on, so I know. Bro, we went over all this in class. What's up with all these lectures, boy? Oh my gosh. Okay. Now we're starting to see some shit I remember. Bro, seriously. I'm using my hand. Okay, yeah, we did this already. So, wait, did we do that? Yeah, we did this already. So we're right here is where we want to be. 32, at about 32 minutes. But I want to go to the end. Oh my gosh, so I'm gonna have to watch for 30 whole minutes. Oh my gosh, I'm gonna cry. We end on this page. Oh. Bro. So we end on this page. What the fuck? It's only a couple pages. Find the amount of work? Yeah. We only go over this many pages. 1, 3, 5, 7, 9, 10. 10 pages. So we have about 10 pages left after. I bet. Cat, 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 kitty, cat, cat. Bro, I didn't even study for real for the last exam. You're getting ready for the long weekend? Me too, bro. No class on Monday. So hype. Bro, it's a pencil, dumbass. You don't understand. Bro. So you're telling me when I write on my paper, you're gonna be smacking my hand like that. You're so nosy, dude. Let me see if this shit's dead or not. Oh, bet. Bro, that is my pencil. I'm gonna have to use that. Nope, that's my packet. I'm taking notes in. Okay, so we gotta go to internal combustion engines. Thank you.
So here's another real world engine. We're going to have a large truck that when it moves at 55 miles.
Wait, hold on, dude. I need my equation sheet. Just so I can move ahead of yo dump. No, I'm kidding. Okay, thermal efficiency equals watts over heat. Bro,
miles an hour is going to burn 0.2 grams of gasoline, and they give us what's called a weight and heat of combustion. So this is the energy that is released when we burn those gasoline droplets.
20% efficiency.
It's going to run at 25 cycles a second, and we have a 20% efficiency. The density of our gasoline we use is 0.7 grams per milliliter. Is that a realistic number? Gas is less dense than water because it floats on water. So that number is less than 1.0, the density of water. So that looks pretty good. Let's see if we can find how much work we get out each cycle. So again, our thermal efficiency is our output goal over Q.
Bro!
So still, if you like, put
I have to sell those clothes. Get out of there. And cat hair all over them. Get. Fucking hate these damn animals. Go take a nap in your litter box. We need a calculator. How does this screen look like that? Or just that angle? $10,000 joules. Yeah. This is per cycle. How do I know this is per cycle? Okay, well, this is per cycle, I guess. What do we determine how much work? Okay. So the thermal efficiency is 0.2. So we have 0.2 equals work over 10,000 joules. Yeah. And so our work is going to be equal to 0.2 times 10,000. So 2,000 joules equals our work. Our work equals 2,000 joules. And that's what he got too, boy. That is a free question.
Our goal up there, so we can distinguish between those two outputs. The QH we release is going to be a latent heat. So if we take our mass per cycle times our joules per gram that we burn, we're going to get out 10,000 joules per cycle. That's our QH. Running at a 20% efficiency, we're going to be getting out 2,000 joules per cycle. Now that doesn't sound like much, but if we're running at 25 cycles a second, the time for one cycle is 1 over our frequency, and we learned that in Physics 1 in waves. So every cycle only takes 1/25th of a second, or 0.04 seconds. So the cycle is going to occur very quickly. So remember, power is work divided by time. So even if the work isn't all that big, very short time, we get a high power for it. Now we want to find out how much heat is discarded every cycle. So if we take our input energy, it equals our two outputs energy, subtracting over the work, this is going to be our waste heat.
Oh, okay. So we see from this diagram here, we know our waste heat is going to be QC minus QH. The absolute value. This is the difference between QC and QH. Why is he using a W when W equals oh, work. No, okay. Yeah, I'm tweaking. I was thinking QC meant yeah, I don't know what I was thinking. Yeah, so that's just how much heat is being wasted as heat, you know? In an engine, how much of the energy is being wasted as just heat to the atmosphere. Okay, so we know QH is 10,000 joules. We know QC is what we're solving for, and work is 2,000 joules. So I'm getting QC equals 8,000 joules. Yeah, that's what we got. Per cycle.
And again, this is going to give us how many joules per second, which go to our water pump size. We've got to make sure we get rid of that waste heat. Otherwise, our engine isn't going to operate efficiently, and it may break if it gets too hot. So again, this is something that's very important to look at too.
Bro.
Let's see if we can find the power delivered by each cylinder during its operation. And I'm sorry, that's not really well in focus. See if I can get a little better. And again, if something's out of focus, part of it could just be the speed of the internet you're using. So when I watch Zoom videos, they're different for me at home than when I'm at Kirkwood. So again, if you have trouble seeing these things, try to make sure you've got the handouts printed ahead of time so that it's easier to see the numbers. We know that power is work divided by time.
Over time.
So if we take our joules per cycle and divide it by our seconds per cycle, we're getting out 50,000 per cycle, or 50,000 watts. That is a pretty high amount of power.
What's our second? 0.04. Nope.
For most engines, it's far more efficient to be using horsepower. So we'll have 1 HP at 746 watts, and we're getting out 67 horsepower delivered. Now at the moment, that may not sound like it's all that much. But remember, this is just talking about one cylinder. So when you're talking about a large truck, it's probably got 8 cylinders minimum to make this thing work really well. So that is what comes out at the engine. How much gasoline are we going to burn every minute? Well, at 25 cycles a second, and then we multiply by our grams per cycle, that would give us grams per second. But when we buy our gasoline, we don't buy it in units of mass, we buy it in units of volume. So I'm going to get rid of grams and be having milliliters. I'm going to change my milliliters into liters, and then I'm going to do this for 1 minute. So for
Fuck.
For 1 minute, we're going to burn about 0.43 liters of gasoline.
Miles per gallon?
In more conventional units, this is about 16 ounces or a pint of gasoline every minute for
Crazy.
this. Let's see if we could change that into units of gallons per hour. So I'm going to take my liters per minute, and every gallon is 3.78 liters, and then 60 minutes in a given hour. So notice our minutes cancel, our liters cancel, and I get 6.8 gallons per hour. If you've ever driven a large vehicle, you can see that fuel gauge over an hour definitely have that needle move for that. Why would this be neat to know? Well, at the bottom, if we know how fast we're going and we know how rapidly we're using our gas, as we multiply these, we find that we get 8 miles per gallon. So this...
Oh, so you do 55 miles per hour and you divide it by 6.8 gallons per hour. And the hours end up canceling, and you get 55 times 6.8. You get 374. What the fuck? Miles per gallon. Hello? Hello? Did I do it? Oh, I'm an idiot. 55 divided by 6.8. I have it written on my paper. I just didn't do that in my calculator. I was like, what? How's that possible? 8.08 miles per gallon. And I have to plug this in. Where's that cord at? Here.
This could help somebody try to figure out, based on these conditions, what mileage they could expect for this. And if this was not sufficient, they would have to figure out a way to maybe to try to improve those things. So I think this is a good place for you at the moment to take a break, and then we're going to come back and look at our next two
Taking no damn break.
thermodynamic devices.
Where's my water? Oh.
All right. Now we're going to get into types of applications that will sound a little odd in terms of the way that heat is going to move. We know in a heat engine, heat flows from a high temperature to a low temperature region.
Okay, wait, let me write this first and then he can explain this bullshit. Oh, I thought this was... My keyboard's not plugged in. Okay. So let's draw a PV diagram. Pressure, volume. Okay, we have a cycle. It's a standard cycle with I here and F here. And 1, 2, 3 is normal again. And our shaded region is the middle up here. W cycle, which means the work of the cycle. Work of 1 is going to equal 0, of course. Work of 2 equals negative area. Oh yeah, because it's direction. So is volume increasing or decreasing? Volume's decreasing, so well, 2 is increasing. Yeah. It's gonna be greater than 0. And work of 3 is gonna be less than 0. Oh, in a cycle, so since it's a cycle, we know the conservation of pressure times volume. I forgot what that's called. Equals PF times. It's like conservation of momentum, kind of. So net temperature equals 0, of course. It starts at the same, ends at the same. Thus, internal energy, the change in internal energy in the whole cycle equals 0. So delta U equals Q minus W. So Q equals W. Bro, who was calling me for 1 millisecond? Ice Sunday 2:30 to 4:15. Bet money, boy. The surroundings do net external work on the gas, removing heat from the gas/system. Yeah, because if work is negative and heat is negative, then we know that heat is being removed from the fluid, the gas. Yeah. So let's see what they're saying over here in the fridge / air conditioner. Refrigerator. / AC. Okay, so we obviously know we have TH. We have our here, we have our work that goes out. Oh, work going into the body of gas. Work goes in, heat comes out, and cold goes in? How's that possible? Thermal COP, what is that? Over our input. So our output is Q and our input is H, right? Or input is W, right? Yeah. Cop equals Q over W equals QC over QH minus QC, right? Is greater than 1. Yeah, it's always greater than 1. What? If QC is in the numerator, wait, QH, I think he's mistaken. QH should be in the numerator. Because we can't make the assumption that it's greater than 1 if it's QC over QH minus QC. You need to know how large QH is for you to know that, yeah, it's Q, yeah, wait. Okay, we'll see. I think it's a typo. Because we can't make that assumption. We don't know it's greater than 1. Unless we know explicitly that we would need to know, especially QH's size, and particularly in reference to QC's size. So like QC could be 1 and QH is 4. That's not greater than 1. It's 1/3. Which is significantly less than 1. Okay, TH. This is the same. Heat pump's the same. Heat pump's the same. We're dispelling heat, inputting cold, and also inputting a work. And this comes from TC. Like, we know that QH over QH minus QC has to be greater than 1. Because we know the denominator has to be smaller than the numerator. Unless QC is negative. But I don't think that's possible. Negative joules? Joules is a scalar. Yeah, joules is a scalar. Yeah, I don't think. Wait, maybe Q can be negative? Maybe joules can be negative. Means heat is being lost. Okay, let's listen.
All right. Now we're going to get into types of applications that will sound a little odd in terms of the way that heat is going to move. We know in a heat engine, heat flows from a high temperature to a low temperature region, and that heat going through the gas forces the gas to output work. We're now going to be looking at refrigerators, air conditioners, and heat pumps. And some people say this is like a heat engine run in reverse.
Yeah.
So what I want you to imagine we have is a high pressure, low volume gas, where we're going to drop that pressure. We're going to then let that gas expand, and then we're going to compress that gas back to where we start. Remember, the work for a cycle is the area of the enclosed part. So since we come back to where we start, the net change in temperature of that cycle is 0. So in our first law of thermodynamics, if delta U is 0, Q minus W implies Q equals W. And what does that mean about this particular graph? Well, in this picture, our output work has less area than our input work.
Mm-hmm.
So the total work is negative area enclosed. Now, what does that mean? That means we have a net input of mechanical energy. So let's have you write that down. A net input of mechanical energy. In magic marker crayon level physics, I like to call this work done on the gas by the surroundings. So we're going to be forcing the gas to do something in this manner. So when we look at this equation, remember we said our area is enclosed. So for this entire work, let's add a negative to this spot. The surroundings are inputting mechanical energy, and that makes Q here negative. And if Q is negative, that means heat is going to flow out of the gas.
Mm-hmm.
So this is going to be run in a different manner than our heat engine. So in terms of our energy flow, it's going to look like these. And I'm going to split this up into 2 different applications. The first is going to be a refrigerator or air conditioner. And when we think about those devices, they're designed to make something cold even colder. So they are going to try to remove heat from the inside or the indoors by inputting work and delivering that heat to the outside of the device, like the kitchen or the outdoors if it's an air conditioner. So we are moving heat effectively from something cold to something hot. And that is opposite the 0th law of thermodynamics. Heat always naturally goes from hot to cold. So how can it go from cold to hot? That's going to depend on how these things operate. So instead of talking about an efficiency, we're going to talk about this as a thermal COP. And the COP stands for coefficient of performance. And it's going to measure what is our output goal over our input action. Now there's only one output energy, and that's QH. But the goal that we care about in a refrigerator and an air conditioner is QC, removing heat from a cold environment. So imagine this is where we're living in summer, the TC environment, and we're dumping QH to the outside environment. So a typical refrigerator air conditioner will have a value of 3. And what that means is for every 1 joule of input work, we remove 3 joules of heat QC from the cold environment. The work, again, is the difference of those 2 heats. So if we get rid of those, we're going to get this as a fraction. And this fraction is going to be bigger than 1. So we couldn't really say an efficiency. Because if you had a COP of 3, it's not 300% efficient. It just means for every joule I put in, I remove 3 joules of waste heat. Now, sometimes in the industry, on heating, ventilation, and air conditioning, we call this a SEER rating. And that stands for a seasonal energy efficiency ratio. And the ability of an air conditioner to remove heat is going to really depend on the temperature of those regions. So it's going to be easier to run the air conditioner in spring and fall than in the middle of summer. Now for these, we actually have units, and it's all about the BTU hours that we remove. And let me say that better. BTUs per hour that we remove divided by our watts. So if you ever buy a window air conditioner, how good is that air conditioner? There's 2 things you got to look at. This is going to represent what it's able to remove every hour, and this is going to represent the power of the electricity. So if you divide those 2, you'll get a ratio telling you really how effective this device is. So just because something has more BTUs does not always mean it's the better device, because you also have to pay for the energy that goes in. For our heat pump, what we're going to look at is energy that we pull from outdoors.
Where do flies
and we move
go?
it indoors.
Divide and conquer. You doing recursion? Wow, bugs don't. I thought bugs like just. Yeah, I guess not. Then there'd be just a whole bunch of dead bugs on the ground.
So our
Yeah, I guess that
thermal
makes
COP
sense.
is going to be our goal, and that's what we care about right here, more than what we're extracting. So our output goal is going to be our QH, and the work is still going to be the input. This is what we've got to pay for. So if I take my work and I write it as the difference of those 2, I get a different fraction. So notice this and this are very different. So if you have a heat pump, it can also serve as an air conditioner, but you're going to have different SEER ratings for those. So a typical heat pump that's ground source has a value of about 18. And that means for every 1 joule input, I'm going to get out 18 joules delivered to my indoors. Now, how can I take this and convert it back to this? Well, it would be nice if we could get the SEER rating to be dimensionless. So if we take our watts over watts, we could convert that back into BTUs per hour by multiplying by 3.41. So if you know the CLP, that's how you could change it into more of heating, ventilation, and air conditioning units. And some of you going on in mechanical engineering, if you get into those areas, great. You'll understand a little more what they mean. Now again, this looks like it's opposite Mother Nature, trying to take heat to go from cold to hot. So on your next page, I'm going to show you how it does that. Refrigerators are not cheap. When you go to buy a brand new refrigerator, you're looking at easily $500 to $3,000, depending on what you want to buy. So we've got to make sure we know how these things operate and how they run, right? Even used ones are becoming more and more expensive. So I want to give you the concept of how these things work so you know a little better on how to take care of it. So it's all going to start right up here at this expansion valve. And what we're going to let the gas do at that point is to undergo a low pressure expansion. And as we let that happen and we drop this pressure, our temperature rapidly drops. So these coils that are inside the refrigerator and freezer, they're going to absorb QL, which is Q load, or Q low, or QC for cold, whatever you want to use, from the food. And that's going to keep things cold. But now we've got to get rid of that value. So once we've absorbed it, we're going to put it into here, our compressor. And if we undergo a very rapid increase in pressure, we get a rapid temperature increase. And that makes all of these things back here really hot compared to the surroundings. And that allows us to remove that waste, QH, from these coils. And that's going to involve conduction, convection, and radiation. And as we mentioned before on the heat engines, all of these depend on area. So the more area of all of this metal, the easier it's going to be to release that heat. So if you have an older type of refrigerator, they recommend at least twice a year to move it away from the wall and then vacuum clean all of those coils, because you'll get dust and hair built up on it. And all of that insulating material is going to make it have to work harder to release that heat. And that could shorten this thing's lifespan. So for really nice newer refrigerators, they have all of these coils sealed so that dust and things can't get on them. And then they have a fan that blows that air out to stay away from it. And that tries to allow us to remove that waste heat. So all we're really doing is making heat go in from hot to cold. Just depends on where it is. What part do we pay for? We pay for the work that's done on the gas as we undergo a very rapid compression. So that's the input mechanical energy that allows that to come out. When we want to run this as a heat pump, it's kind of like doing an air conditioner refrigerator to the outside. We make the coils of our heat pump try to absorb heat from the out part here, and then we input work to deliver it inside of our home. So that makes this the goal compared to what we have over here.
Wait, what?
So let's do an example to come out. When these coils sealed so that dust and things can't get on them, and then they have a fan that blows that air out to stay away from it. And that tries to allow us to remove that waste heat. So all we're really doing is making heat go in from hot to cold. Just depends on where it is. What part do we pay for? We pay for the work that's done on the gas as we undergo a very rapid compression. So that's the input mechanical energy that allows that to come out. When we want to run this as a heat pump, it's kind of like doing an air conditioner refrigerator to the outside. We make the coils of our heat pump try to absorb heat from the out part here, and then we input work to deliver it inside of our home. So that makes this the goal compared to what we have over here.
If there's no heat outside, then how does it absorb heat?
So let's do an example with that. And I want to talk more about heat pumps to start off with, because they're kind of a big thing now, especially if we can make them geothermal, but they are very expensive to put in compared to a standard furnace.
Okay, stop. Let me read the question. An electric heat pump is used to keep temperature 68 degrees Fahrenheit home. Okay. We want that to be in Celsius, so we do 5 times 68 minus 32. Oh no. 68 minus 32 times 5 ninths. We get 20 degrees Celsius. Oh, I already knew that. I'm such an idiot. I have that. I know that. 20 degrees Celsius. What am I thinking? While the outside of the home is at 10 degrees Fahrenheit. Okay, this one I actually don't know. 10 minus 32 times 5 ninths. Negative 12 degrees Celsius. The heat pump has a COP of 5, and the walls/ceilings of the home have an R value of 20 feet per hour, 20 feet squared hours Fahrenheit per BTU. Are you fucking high? The home is 20 feet by 35 feet by 12 feet. Find the heat loss for 30 days if this temperature difference is maintained. Dude, half this class is just unit conversion. This guy loves his unit conversions. Okay. So we're trying to find delta Q over delta T. And that equals area times the hot temperature minus the high temperature minus the low temperature over the R value. So our area is 20 by 35 by 12. Does he keep it in feet? Yeah, he does keep it in feet. $840 feet squared? Where does that come from? Oh, he does the area of each thing. He does the area of each wall. Is it a square or no? How does he get 840?
So we've got an electric heat pump that is going to keep the inside of our home at 68 Fahrenheit. And that's while the outside of our home is 10 Fahrenheit. Very realistic numbers for wintertime. The heat pump has a COP of 5, right, which is a pretty good value. Now on the previous 2 pages, I said 18. 18 was in the SEER units, SEER. Right? So we could take our 5 times that conversion number we found to put it into SEER units. The ceiling and walls have an effective R value of 20. And then again, these are the contractor or the Menards units. And then this home is 20 feet by 35 feet by 12 feet. So if we think about the house, this is a 1-story house of 700 square feet. That's probably like a smaller 2-bedroom apartment or kind of a big cabin or a big 1-bedroom apartment. but we're not talking about a huge house. So we're going to try to figure out the heat loss that goes for 30 days. So we're going to lose heat through the 4 outside walls and the roof. We're not going to have any heat loss through the floor because that's insulated by the earth. So we're going to go back to our conduction formula. We're going to put in all of our numbers. Now again, those aren't metric, but that's okay. A lot of...
Wait, I'm confused how he gets this area to be 840 plus 480 plus 700. 20 by 12. Oh. So we have 35 by 12 as well. Okay, so 2 of these walls. What happened? 2 of these walls. 2 of these walls. And then our ceiling. Our ceiling is going to be 20 by 35. So we have our area. Okay, I guess we do get the same thing. 840 feet squared plus 480 feet squared plus 700 feet squared. Okay, now let's add all those together. We get our area equals 2,020 feet squared. So delta Q delta T equals 20,020 feet squared times 68 minus 10, 58 degrees Fahrenheit over 20 feet squared hours Fahrenheit by BTU. So our BTUs come up top, feet cancel, Fahrenheit cancels, so we're left with 2020 times 58 divided by 20. We're left with delta Q delta T equals 58 BTU per hour. Okay, and now we have 30 days, 24 times 30, and then this times this. I get 4,217,000 BTUs, yeah, per month. 4,217,760 BTU per 30 days. In this case, it's just months. Okay.
A lot of science isn't always using metric units. So once we put all of this in, we get our BTUs per hour. This is how much is lost. So if we want the inside to stay at this temperature, this needs to be replaced every hour. Now it could be done with electrical heating, it could be done with a gas furnace, it could be done with a coal furnace, or it could be done with a heat pump. This is not a huge amount of heat. We're going to then take this thing and we're going to multiply it out to try to find our BTUs for a given month. And this is the number we get just due to conduction. Right? This needs to be replaced every month. Now we also have convection and radiation that's going to be removing from the house.
To heat the home over a month, is it? What is it? What is it asking?
Under what is that change is being so you're going to work first balance or next again. But once we pause, you forget that's going to be removing from the house. but this is simply the one that we're calculating right now.
Why'd they change it to $1.65?
So to find the cost of using a gas furnace at 85% efficiency, each therm is 100,000 BTUs. Now, if I'm at 85% efficiency, that does not mean I need 15% more. What that really means is I need to take our number 1, and you can do that on a calculator, just watch me. Run it. 1, and then I divide by 0.85. So I actually need 17.6 more percent of our value. So that's why I'm dividing by the 0.85 right here. And then I'm going to multiply by the cost of a therm. So for 30 days at these temperatures, you'd have a gas bill of $81. Now, it's actually going to be higher than that because of your water heater. We may have temperatures that are lower than 10.
Wait, what?
But if we were just sticking with that number, that's going to be our cost. Now, what's kind of interesting is our bodies naturally release heat by convection and radiation.
1.05.
And an individual person releases about 72 kilowatt hours of energy every month due to radiation from their bodies. So that's $7.20.
Makes no sense.
So some people could say, hey, this is a great idea. I'll get more animals living with me, and they will radiate heat. But you've also got to be paying to raise those animals. But I think it's kind of neat to put that in a dollar value. If we did all of this with electrical heating, right, where we run wires in our baseboards, we could take our BTUs and change them to joules, and then a kilowatt hour, a kilowatt hour is 3.6 million joules, and we have 10% of a dollar, 10 cents per kilowatt hour. For electricity, $123. Now again, this is a small 2-bedroom apartment with 4 walls. That's a big bill to write every month. And we're talking about a pretty good value here for a wall. So maybe instead of doing those two things, we're going to try to heat this thing with a heat pump. So remember, the heat pump
the work is going to be equal to the thermal efficiency times QH. Oh wait, no, in this we're using the work equals the thermal COP, or well, the heat divided by thermal COP. Do I have any trash over here? Oh yeah, I do. Never mind, doesn't matter, I guess. Okay, what was I doing here? Kind of zoned out. I'm just copying his notes. I don't give a fuck, dude. work goes in, heat goes out, and cold goes in. Wait, how can we have work in watts? I thought work is supposed to be in joules. It's supposed to be a unit, not a rate. Yeah, and that's easy to convert. 0.343 kilowatts. And then we just multiply that by how much it costs. 0.1 and times, what are we doing? 720 hours. 24.72 dollars.
Pump is going to steal heat from the outside by getting the coils really, really cold. And as it absorbs this QC from the outdoors, we input work to compress the gas to deliver this QH back indoors. So this is our goal. This is our input. Right? So if we take our BTUs per hour, we could change that into watts. And this is the rate of QH that we're going to be needing to replace our BTUs per hour. Now I changed this into units of watts because the energy that runs a heat pump is electrical energy. And we often buy that in units of kilowatt hours. So this is our rate of this. So our rate of input for work comes out to be 343 watts or joules per second. Divide that by 1,000, we get 0.343 kilowatts. I'm going to multiply that by hours. That gives me kilowatt hours.
Heat that must be removed from the water in order to change it into ice. Okay, so we know COP equals, we're cooling it, so it's QC over QH minus QC. We also know that Q equals the Q from 20 to 0 plus the Q of ice plus the Q from 0 to negative 10. Okay, so we get Q equals 20 to 0 is just going to be MC delta T plus L fusion plus MC delta T of ice. So the mass is going to be 3 kilograms throughout, so we get Q equals 3 kilograms times the C of water is 4187 joules per kilogram. 4187 joules per kilogram. And then that's going to be multiplied by our change in temperature, which is 30 degrees Celsius. Oh, kilograms Celsius. Joules per kilograms degrees Celsius. Joules per kilograms degrees Celsius times 30 degrees Celsius plus The mass of the ice is going to be 3 kilograms again. We're going to have latent fusion, which is going to be 334 joules per gram, or 0.334 joules per kilogram. And that's going to be plus 3 kilograms of ice again, times the specific heat capacity of ice, which is 2090 joules per kilogram degrees Celsius, and then times our change in temperature. Oh, our change in temperature originally is from 20 to 0, my bad, is 20 degrees Celsius, and then our last delta T is 10 degrees Celsius. Okay, so degrees Celsius cancel, kilograms cancel, kilograms, 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 Celsius, Celsius, kilograms, kilograms. So we're left with this huge number. Let's make LF is right. It's 540 calories per kilo. Oh, he converted everything to calories per kilogram. Okay, let's see if we get the same number. 3 times 4187 times 20 plus 3 times 0.334. Yeah, 1 million. Okay, so I think it's a problem with the fact that this is 0.334. Latent fusion. So this is actually going to be a different number. So we have 3 times 4187 times 20 plus 3 times, I think it's 334,000 plus 3 times 2090 times 10. Okay, we get Q equals 1,315,920 joules. Okay. You got 905 joules? Same thing though.
Now multiply that by 10 cents a kilowatt hour. So if I were running a heat pump with this thing, it would only cost me $24 a month. That's a savings of almost $100. So if you were living in kind of limited financial resources, this sounds like a pretty good thing.
Yeah, I would agree with what Fury, or however you say that name, what he just said. I don't do anything but study or do work at my desk. I chill in other places. I don't do anything but work here.
But there's a problem.
I mean, I don't even go on my PC unless I'm doing work, like at all. Nothing else
here.
on my PC.
We said the indoors was 68 Fahrenheit, but the outside,
I already did all this.
I believe we said was 10 Fahrenheit. Yes.
So wait for his ass to
So
catch
when
up
you
to
hear
me.
10 Fahrenheit, one of the first things you think of is that's cold, but that's below freezing of water cold. So if our coils were exposed to the air outside, moisture in the air would condense on those coils, and that would frost those coils. It would be very hard to absorb heat from that air if frost built up on them. So some people say, well, let's just run an electrical wire to heat those coils. Well, that's going to be a problem because we need those coils to be colder than the environment to absorb heat. So if we're heating them to get rid of the frost, that ain't going to work. So even though the math tells us, hey, we're going to get this number, this setup right here is not really practical. Because if this gets below freezing, it's really tough to extract heat because any water present is going to be as frost or ice blocking that flow. So I'm going to show you how to improve this later on. But it's neat to be able to at least see how we could do these calculations. A more typical one. Let's talk about the cost of making ice. Freezer operates with a COP of 2.5. That means for every 1 joule of input, we're able to remove 2.5 joules of QC. And we're going to use that to change 3 liters of water at 20 degrees C into ice at negative 10 degrees C. Now I picked 20 degrees C because, you can write this down, 68 Fahrenheit, room temperature. So you're pulling water out of your tap line, and you're going to have a big party, and you need lots of ice to keep things cold. Why did I choose to take it below zero, where water freezes to become ice? When you put water in your drink, you don't want that ice to immediately start melting. That will water down what you are drinking. So we're going to go colder than zero, so it stays in the solid phase longer before it starts to melt. So let's see if we can find the heat we need to remove to make all this happen. So we've got a heat to go from 20 to 0, a heat to freeze, and then a heat to go from 0 to negative 10. So this goes back to our very first lecture. A specific heat changing temperature, a latent heat changing phase, and another specific heat changing temperature. Now the M's are all the same, but notice the CW and the CI, this is in the water liquid state, this is in the ice state. They are very different numbers. This is half the value of this. So as we put all of this in, we need a total of 315 kilocalories to do it. We know that every kilocalorie is 4,187 joules. So this
I
is
just
what
have to
we
finish
need
this lecture. That's all I have to do for studying today.
to remove. So in your
Is
notes,
this
you
course
could
through
write,
community college?
this
Yes, it
is
is.
our QC. This is what must be removed to make that ice. Now we want to find the amount of work.
I just finished my freshman year. I'm about to go into my sophomore year. And yeah, I'm pretty up to date on the research that's going on. I think, for the most part. I don't know. I haven't really been focusing on it recently.
Work we need to make this happen. So remember, we have to physically make the gas in our coils colder than our region where we're going to absorb that heat. So how we get rid of that heat is we input work, and that raises the temperature to radiate that away.
Wait, what did he say?
So to help us get removed to make that ice. Now we want to find the amount of work we need to make this happen. So remember, we have to physically make the gas in our coils colder than our region where we're going to absorb that heat. So how we get rid of that heat is we input work, and that raises the temperature to radiate that away. So to help us calculate that work, we know our COP is our goal over that work. So when we solve here for our work, we find we need that many joules of energy input. Now we buy electrical energy, which is what's going to run our refrigerator freezer, in units of kilowatt hours. So I'm going to take these joules and divide by 3.6 million joules, and every kilowatt hour is 10 cents. So the cost for our freezer making this is about 1.4 cents. That's a very realistic number. All right. And we said we were going to do this. We said we were going to pick, let me go back a page, 3 liters of water. So that's 3 kilograms. So that's about 6.5 pounds, which is a little shy of a standard 8-pound ice bag that you buy. And when you buy that ice, you don't pay 2 cents for it. You pay several dollars for it. Because not only do they have to make it, but they've got to keep it cold, and they've got to make a profit. Right? And they've got the way to do that in large units of ice, where in our homes we can't do that as easily. So now that we know the cost to make that happen, let's see if we could figure out the heat that we're going to dump into the remaining kitchen. So that's going to be our QH. So we know that our kitchen has a volume space of about 48 cubic meters, and the heat capacity at constant volume for air is 0.17 kilocalories per kilogram degree C. And they gave us the density of our air in kilograms per meter. So we could find the mass of all the air in the kitchen by going back to physics 1. That comes out to be 60 kilograms. When we want to put that back into this to calculate this delta T, this Q.
Okay, wait, what was our QC? Our QC was the 1 million. 1 million plus 2.5 times 1 million. Enter, divided by 2.5. Okay, I got QH equals 1 million. Wait, that's not possible. Oh, I guess it is possible. I guess that's what he got. 1,840,000. I got 842,288. But that's because he rounded this number. Stupid reason. I don't know why he did that. Okay, and we can solve for our delta T because we know QH equals MC delta T. We know that M equals 3 kilograms. We obviously just solved for QH. Our C equals 0.17 calories per kilogram, so 0.17 times 4187. You get 700. We get C equals 711.79 joules per kilogram degrees Celsius. Okay, so let's do 1 million divided by 711 divided by 3. Hold on. 3 kilograms? Are you sure it's only 3 kilograms? Oh no, it's 60.4 kilograms. Oh, mass equals density times volume. I don't know what mass I was just using. Equals 60.4 kilograms. I don't know what mass I was just using. 60.4. Okay, we got our delta T equals 42. I got 42.8, so 43 degrees Celsius.
Q is our QH. That is what gets dumped out. And that's equal to what we pull out of the water plus the work we put in by conservation of energy. So we got to add those two things together. So that's the total joules that gets dumped out into my kitchen. And then all I did is change it to kilocalories by dividing by 4,187. So now that I know the calories that are going to go into my kitchen air, I find that's going to change by 43 degrees C. Now, how hot is that? That's a pretty high temperature change.
43 degrees Celsius.
We could find the change in Fahrenheit by just multiplying by 9/5. Not 9/5 plus 32, just 9/5.
77.4 degrees Fahrenheit.
And our kitchen doesn't get hot. So why is this number not realistic?
That's insane.
This was in a
temperature
book I remember I
change.
was reviewing at one time.
If
and it
from
just
room
bothered me
temperature,
because you get to this answer and it feels misleading. That if we continue to make ice,
145
the
degrees
kitchen is going to be
Celsius.
unlivable.
Or degrees Fahrenheit.
Well, this is just what it would do to the air. But remember, because the air is moving in our kitchen, it's going to transfer heat into the mass of everything else in our kitchen. And everything else in our kitchen is going to have a far bigger mass than just 60 kilograms. Yeah. So it's going to be absorbing that heat too. So that way we don't have to worry too much about the heat that we're going to be dumping into our kitchen as we make ice for our party. So that's going to be the end of applications of thermodynamics. So I think it's a good time for you to take a break, and then we'll have one more video where we're going to talk about how to optimize how each of these things work.
Nope, that's for Monday, buddy.
I'm going to write that as a separate lecture to make it easier for you guys to space the time out watching these.
That's for Monday, buddy. Okay, let's see what you guys are saying. How many hours do you study a day? I don't know, bro. I don't really count. I just study, bro. Yeah, no, I don't like working on LLMs. I think it's pretty boring. I don't know what, I don't see that the application, right? I don't see where, because I want to work on something that will positively, like, change the world. I don't know how LLMs are going to positively change the world. I mean, they're cool, and they're great tools, but I think I wanted to work on something a little bit more impactful. Jeffrey Hinton, yeah, I know Jeffrey Hinton. Yeah, LLMs have a lot of issues. Yeah, I could look at something like that, possibly. Seems pretty interesting. You started school already? This is my summer classes. So yeah, I've started my summer classes already. I need to go play tennis, but I need to wait for it to be nice outside. And that's not gonna happen until there's a flood watch right now. That's not gonna happen until 6 p.m. It's not gonna be sunny until 6 p.m. 6:30 p.m. to be exact. Okay. Hold on. So 6:30 p.m. is when is when I will go. Yeah, weather's jacked. Yeah, it is, bro. It's raining a lot outside. It's raining a lot outside. I'm studying with 0 power right now. That's crazy. That's dedication, bro. Okay, what was I doing? Oh yeah, I need to get... With Rabbit, I don't know what's happening with Rabbit. They made the Rabbit R1, right? Yeah. Rabbit, yeah. Rejects NFT scam allegation. Yeah, these are all like shitty news sources, so I don't think it's really anything I should concern myself with. Yeah, no, I need to do a lot of neuroscience research for sure. it's foolish trying to make a machine learning model that can mimic the human brain without fully understanding the human brain. That's why we'll never get. Okay, stop saying never. But that's why it's going to take a very, very long time for us to reach AGI, because as of right now, like, and in terms of AGI, I mean like self-conscious artificial intelligence. I mean, AGI is a very subjective term. Like, people are like, oh, ChatGPT is AGI because it has general intelligence, and it does have general intelligence. But in terms of like what I think AGI means, requires like consciousness. And if we can't even understand human consciousness, how are we going to make something that can replicate it? It's not. I mean, unless somehow we get extraordinarily lucky and someone writes this algorithm and they don't know what's going on, kind of like how neural networks started. You write a piece of code and it just does something and you don't know why it does that. That's the only way I see us in the near future getting consciousness in machines. Yeah, I think it's going to be a long, long time before we get real AGI, where we get real self-conscious machines. First, we have to understand consciousness itself, and we're very far from that from a biology and chemistry standpoint. That hair suits you better. Looking like J. Cole. Thanks, brother. Yeah, I'll look at that stuff. I mean, I probably wouldn't do any of that seriously. I need to focus on school right now. The classes I'm taking and the classes I'm going to take is really what I'm focusing on. I'm gonna eat my other sandwich. It was something I kind of realized when I started studying it, like math and physics, all this stuff. I really liked when I started studying it. I'm not from the UK, so I have no idea what A levels is, but I do math, physics, and computer science in university, yeah. Then do one at uni, yeah, I don't know what you're talking about. I did math, physics, and, well, just math and physics in high school as well. I'm 19. I turned 19 this year. A levels are taken at 18 and you do 2 to 3 of them, or 3 to 4 of them. Yeah, I don't know what A levels are. Uni, you just do one thing. Yeah, uni, you just do one thing. You can't just study physics. It's not possible. You have to have an understanding of math to understand and do physics. You know, and computer science, you also can't do computer science without learning math. It's literally not possible to learn computer science without learning math. It's genuinely not possible. So I think college is the same, though. University is the same for the most part in the UK and in the US. Because I'm going to do my PhD at Oxford, and it's just like, you know, it's the same. I don't know what else to say. Like, it's just pretty similar. I mean, maybe they structure it a little bit different, but overall you learn the same thing. What do you want to do a PhD in? You're currently at Oxford. I want to do a PhD in machine learning and neuroscience. That discouraged me. LMAO, currently a med student. If you're a med student trying to do a coding camp, then you're not going to become a computer scientist. You need math to become a computer scientist. To learn how to code and program, you do not have to learn math. I mean, to some extent, but if you are a med student, then you're competent enough to be a programmer for sure. And if you want to do web development, you don't need any math at all. Yeah, you only need math if you're becoming a computer scientist. If you want to become like a software engineer or a developer, you don't really need math. I mean, there's some situations where you do, but anything you would need, ChatGPT can just tell you how to do it anyways. It can't do it itself, but it can tell you how to do it. So don't get discouraged. Unless you want to become a computer scientist, then you're gonna need to learn math at some point. Yeah, solely interested in coding, then yeah, you don't need math. You've been using chat for your web development projects? Of course. Every step of the way. It would take me 5 times longer to do everything without using chat. And I'm also not a web developer, so I don't really care. Well, I do care. Well, not really, actually. But yeah, no. Why would I not use ChatGPT? I'm solving a real world problem, so I'm going to use all the tools that I can to solve the problem. If I didn't use chat, then I would just put myself and the person I'm making the website for at a disadvantage because I'm not as capable doing it myself as I am doing it with ChatGPT. I'm not saying like ChatGPT is more capable than me. I'm saying that me using ChatGPT is better than me not using ChatGPT. I mean, it's like trying to do something. Like, at what point is it like, okay, I'm just gonna use these tools because you could be like, oh, you're doing it, but you're Googling stuff. You can't Google stuff. But I'm better at coding using Google, and now it's just ChatGPT is another step. So I assume in the future it's gonna be even crazier. But you're a mathematician and you're using a calculator. I'm not a mathematician, and I am using a calculator, yes. And mathematicians use calculators as well. Yeah. That's my response to that. I've never met one mathematician in my entire life that's not used a calculator. I mean, we can't use calculators in like calculus and stuff. Like on our exams, we couldn't use it. And I did very well on those exams, but you don't have to do calculations that require a calculator. No one's taking the natural log of a square root in their head. Not possible. Damn, 1 out of 45 is crazy. I will put it like this, and then doesn't say anything. What use does a calculator have? What use does a mathematician have for a calculator? What are you talking about, bro? What? What do you mean? To help them solve problems. Cheating out of yourself from the ability to think out of your own volition that exhibits your own agency and not of that of AI. As I said, the same things. What are you saying? You think I have imposter syndrome? Bro, what are you talking about? You need to have some context. You need to have some context to my life. It would contribute to it if you did. Yeah, of course. If I was genuinely trying to learn web development, then I would not use ChatGPT. Because then you're not, then you're genuinely just not a good web developer, right? I mean, like when I'm solving calculus problems or physics problems or machine learning problems, I don't use ChatGPT to do it. I may use it to help me learn, but the goal of me using ChatGPT in that context is to help me learn, and then so that I'm able to do the problem myself. When I use ChatGPT for web development, I do not have the goal of being able to do the problem myself. That's not the goal. Because I don't want to become a web developer. So like in this context, like with web development, I can use ChatGPT because I don't care how good I am at web development. It's not what I want to do in the future. I'm just doing it right now because someone had asked me to do it for them. But yeah, I would agree with that. Like if you're trying to become a physicist, but you can only do physics with ChatGPT, then you're not a physicist. 100%. Yeah, I would agree with that. What use does a mathematician have for a calculator? I mean, that's kind of like a, I don't even know. I don't know what adjective to use, but it's like an interesting phrase. Because like the point of being a mathematician is so you don't have to use a calculator. But I honestly don't think that that's true. I think mathematicians are supposed to set up the problems that a calculator would solve. And so you can use a calculator as a mathematician. That's why a lot of mathematicians end up becoming computer scientists, because they have to use computers to solve these complex equations that they've created for themselves. But I think a mathematician is someone who thinks of problems and solves them. And they can use calculators to solve those problems. If it does it faster and better than a human can do it, and consistently, then there's honestly no point in being able to do it yourself. And I'm not saying like conceptual stuff like not being able to solve an integral without a calculator, because then that's an alarming problem, right? But if you're trying to calculate like the speed that a planet orbits around a black hole 10 billion miles away from Earth, there's no point to do that calculation without a calculator, right? Because the goal of the problem is to solve for the speed of the planet. That doesn't matter. It doesn't matter if you use a calculator or not. It doesn't change your ability to find the solution to the problem. But I mean, I've taken higher mathematics, of course. I go to a very good school that teaches a lot of math. And we're not allowed to use calculators in our classes for a reason, because we're trying to learn the concepts. But after you've learned those concepts, if I'm doing an integral now, I can do integrals fine by myself, easily. Triple integrals, double integrals, whatever you want. But if I'm going to do an integral today, I would use a calculator, because I have no point to do that again. And I guess if I was a mathematician, it might be a little bit different. But I would think that not using a calculator would just limit your ability, right? I mean, that's the point of humans developing. Mathematicians are the ones who made calculators. They're the ones who developed calculators. They're the ones that developed the problems that calculators solve, and developed the algorithms that calculators solve these problems. And I don't know why you would not want to use it. I understand if you're trying to learn, that then there's a point not to use it. But in everyday life, there's no point to not use a calculator. Yeah, ChatGPT is literally a better search engine. That's correct. I would agree with that. Have you used AI in your job function at the university, like blatantly? My advisor used it like crazy, but the moment someone like me uses it, I feel like eyes are staring at me, LOL. Your advisors use it like crazy? That's weird. I've never experienced that. I can't use ChatGPT on most of my assignments, and I need to learn the stuff myself anyways if I want to get good scores on the exams. So I don't use ChatGPT or AI to solve problems that I need to learn. But I mean, if someone gave me like an arbitrary task to do, then I might use ChatGPT to help me do it, to make my life, to give myself more time to give myself more time to do stuff that I actually need to work on and learn. I promise you a calculator has no use in higher mathematics. Yeah, maybe at school that would probably be true. Whoever raised the concern of using a calculator to come to an answer depends on what problem you're trying to answer. Yeah, that's true. As you said about the speed problem. Yeah, okay, but that's not mathematics. Yeah, it wasn't. That's kind of like physics. Terrence Tao had to use a computer for like 3 weeks to get an answer. Yeah, exactly. And that's why I think it's like you have to be a mathematician to solve these problems. Because like to get the computer to solve the problem, you have to understand how to solve it yourself first. So that's why you need to be a mathematician to use it, to even be able to use a calculator. If you give me, I keep saying integrals, but I don't know what else to say. If you give me an integral and you want me to solve it, but I don't know how to solve integrals, giving me a calculator won't do anything. I still won't know what to do. But now I know how to solve integrals, so I'll find the derivative and then plug in the numbers at the end into my calculator to solve the integral. So like I still have to know how to do it. But yeah, it does depend on the context heavily. Perplexity is also a decent search engine. Yeah, I've heard Perplexity is like the best free one. There's also Llama, but Perplexity you can actually upload documents as well. You know, mechanical calculators was made for a reason, right? Calculators were made for a reason, to help humans solve problems. Why wouldn't you use ChatGPT to assist in learning? I would. I wouldn't use it to solve homework problems and stuff though. They used a computer to prove four-color theorem. Not using AI to your advantage is just dumb. People who don't are going to miss out. The world creates waves, surf, or drown. Yeah, to an extent. I mean, I would agree with that, but like I objectively agree with that, but there are some things, like you have to give some context a little bit because some people unhealthily use AI to solve problems and help them learn, but in reality they're not actually learning. Because they can only solve the problem with AI. You use AI to teach you maybe or help you solve a problem yourself, but you still have to, at the end of the day, be able to solve the problem yourself without using AI. So to an extent, I would agree with that. Yes, okay. If algorithmic proof is a type of calculator, then I agree. Yeah. I mean, that's all the calculators are, is just a bunch of algorithms. What is your current study strat for STEM? I have a bunch of study strats for different topics. Maybe give me something more specific, like if I'm studying for an exam or studying for what, like specifically. Mm-hmm. Oh yeah, you see his point. Yeah, exactly. I was saying that earlier, that using a calculator would be meaningless to a mathematician who's trying to learn, of course. But a mathematician who's not trying to learn, but just trying to solve a problem, I think it would be to their advantage to use a calculator. Let's say a physics class where you can't leverage a solutions manual. What is a solutions manual? What is that? Is that like an equation sheet or something? What's a solutions manual, bro? I've never encountered one of those before. The back of the book? What's in the back of the book? Oh, they have solutions in the back of the textbook? Oh. Okay, well, how are you gonna learn well, I guess there are some times where you need to see the answer to fully understand like how to solve the problem, I guess. Yeah, I mean, I always try to just do it myself. Maybe to check your answers would be good. Yeah. I'm only capable of doing questions with answers. You for sure need a feedback loop. It's the only way to learn. My homework assignments usually tell me if I got it right on like the website or whatever I'm using. Yeah. And like when I do past exams, I also have the solutions to those exams. But generally when I read the textbook, I don't solve the problems in the textbook. I'm just reading because the textbook problems are always so stupid. At least in my experience. So I don't really do the problems in the textbook. I read the textbook for sure. I follow along with their examples and read the concepts and stuff, but I generally try to do my own. They give us, like the course staff will give us specific questions to answer that are directly related to like what we're learning and what we'll be tested on, and I do those practice problems instead of the answers in the text, instead of the questions in the textbook. Yeah, I mean, when you use AI, like you should essentially just use it as like a TA, right? Like when you're in a class, if you can't solve a problem, you'll raise your hand, you'll ask the TA. The TA will ask you your thought process, how you did it, and they'll tell you, oh, this is where you went wrong. Here's how you can and they'll kind of nudge you in the right direction. And that's a healthy relationship to have with ChatGPT. I think that's a great way, because then it's like you have access to a discussion section all the times of the day, right? I mean, if I only could ask someone questions when I was specifically in class, then I would have a terrible time learning, because I would hold in all my questions until class, and then I would try to go through a bunch of questions in a short period of time. So it's just like you have someone with the ability to help you at all times, which is great. Especially to people who don't have access. Maybe some people are taking online courses and they don't even have TAs. Then it's like, yeah, you're out of luck. Your current lecture is pre-learning from the book to get familiar, then the lectures themselves, practice problems for those lectures, past exams or quizzes. Well, my learning process is different in each class. Some universal things that I do though is read the textbook before lecture, and then I'll go to lecture. Usually lectures are pretty pointless for me because I already know the information that they're teaching, but yeah, I'll go to lecture, and then I'll do the homework assignments. And the homework assignments really where I get the bulk of my learning, which a lot of people don't experience that because they cheat. They use like Chegg or ChatGPT to do their homework, but I genuinely do the homeworks, and that's where the bulk of my learning happens, because you look at a problem, you most likely don't know how to solve it, because let's be honest, lectures don't prepare you to solve problems immediately. They're only 50 minutes. You can't learn, like, especially when you get to the higher level classes, you literally cannot learn the concepts that they try to teach in 50 minutes at lectures in 50 minutes. It's just not possible. They're too difficult to understand and to grasp. So you need to learn outside of class. And I feel like if you do the homework, so I try to do the homework way early so I have a bunch of time. Because I'll sit there doing homework for 5 hours. On a homework assignment that would take someone maybe 30 minutes if they were using the internet and Chegg and calculators and stuff. But I do it for 5 hours because every question I look at it, I don't know how to solve it. I have to read the textbook, try to figure out how to solve it, maybe look at some examples of how they did it, maybe watch a YouTube video, and then now that I have all that information in my brain, I turn everything off and then I try to solve the problem myself. Maybe I'll get it wrong a couple times and then I'll finally get it right. And then that way, each question, I fully understand how to solve each question, and I can just go. Now if I receive that same question again, I could easily solve it because it's almost like memorization. It's ingrained in my brain. And that's kind of what happened on exams. And then when exams come around, I just grind practice problems, and some classes give us past exams, and I'll just grind the past exams. And then usually, literally, almost every exam I've taken in university, I've known all the answers to every question on the page before I even have written anything on my paper. I can just, usually when I look at a problem on an exam, I know exactly how to answer it. And if I get points off, the only points off that I get are possibly minor errors that I made on the exam. I'll pull up my grade scope for calc, because we can just look at all my exams. I actually ended up not doing that well on the final. I got an 86, which is not that good. Wait, what? Okay, they're gone. They're gone. What? Okay, well, I can't see the exams. But basically in calc, I averaged a 98 on exams. And so I only got, the entire course, I only got things wrong. I remember one exam, I think it was the second exam, the only points I got off on the entire exam was for not writing the bounds of convergence on an integral. I didn't say that it converges from whatever the bounds were. I forgot. And that was the only point I got off in the entire exam. And that was so stupid because I got the question completely right, but they took -2 points off. And I remember I was like, okay, I got 100. I got 100%, no doubt about it. And I got my test back, and I was like, how did I not get 100? And I looked, and they were like, and then I emailed the professor. I was like, come on, dude, come on. And they were like, yeah, we can't do anything. Sorry, buddy. Congrats on straight A's. Hard work always pays off. I'm curious if you have read the book Make It Stick. I have not read that book. No. I don't like lectures, not gonna lie. Me neither. They're really boring. Except for physics lectures. I really enjoyed the physics lectures at my school. ChatGPT is on my search bar? Of course it is. I think there's a difference in the difficulty of exam questions because here a first top 25%, etc. is a 70. Yeah, no, that's the same here. The first exam, the first calc exam, the average for the class was a 73 or something. I think I got a 91. That was my worst exam. The second had a 75 average. I got a 98. And then the third had a 71 average, and I got a 97, I think, or 98 on that one. And then physics was the same. I remember the third midterm, I got a 93, and the average, I think the average on the third midterm was no, that was the first. The first midterm, the average was a 69 or maybe a 70, and I got a 90 on that one. But the third one I got a 93, and the average was 76. So I think it's pretty similar. Because here a first top 25%, etc. is a 70. Yeah, I think it's the same here. I don't know. What grades do your friends get? I think the average for like college students is like B's across the board. I think like a 3.5 is the average GPA. Like B's, B pluses. Some of my, I mean, I only have one friend like on this entire planet that has a GPA comparable to mine, and he has a 3.8. But everyone else has like a 2. Some people have 2s, some people have like low 3s and stuff. So yeah. Lectures feel very time consuming, especially since I probably already know it. Yeah, but you should still go to lecture because repetition is key in learning. So, and it helps with consistency as well. Exactly. Because it makes you wake up in the morning. Fucking dreaded walks to lecture. Yeah, no, the 25th percentile still gets like 70s here in the US, or maybe 80s. You have to do really well to get a 90 plus. I'm sure there's people who get 90 plus. There can't be not one person in the entire class that gets a 90 plus on the exam. Doesn't make any sense. I remember in the intro cybersecurity class, the average was a 55. My professor was so mad. He said someone got a 3 on the exam. Yeah, we've had exams like that. 2 is so bad. 2 is honestly not that bad. I think the average, I don't know what the average college GPA is. Can I see like my school? No, that's not true. I mean, that's for... Okay, being 3.5. 3.5. 3.5 is about the average. And then, oh yeah. Wait, the most selective colleges. I think these are for entrances. Yeah, SAT scores. This is for entrance. Good GPA for Granger. Are you high? A 4? I don't know one person who has a 4 in Granger. I think this is... No, to graduate. If you want to stay competitive with the people around you, I think the Dean's List has a cutoff somewhere above 3.9. Yeah, I think so. Yeah. I mean, you receive honors in Granger with a 3.5. So I don't know why these people are saying the average is a 3.8. You get honors, like you get on the first like level. There's levels to the honors list, but the first level of the honors list is a 3.5 at my school. So I would imagine the average is maybe just a little bit below that. Or maybe it's 3.5 is the average. No, I think it's below that. Most people I know don't even have a 3.0. Most people I talk to, at least. I'm going cybersecurity this fall. That's sick. Actuarial exams also have very low marks. Yeah. Also, a lot of those Ivy League schools are riddled with grade inflation. Yeah, and, oh my gosh. Bro, we were just talking about this. I was talking to one of my friends who goes to Stanford, and he's like, yeah, like it doesn't really matter how well you do in a course because you can drop it on the last day. Like you can drop the course after the final. He was saying like the deadline to drop courses is like there's no deadline, or like you can just drop it till the end of the semester. At my school, you can't drop it after like 3 weeks of the class. So you don't even know if you're gonna do well or not in the class by the time the drop deadline comes around. But at some of the Ivy League schools and at my friend who goes to Stanford, you can just drop it whenever. So all these kids have like 4.0s because they just drop their Bs like right at the end of the semester. It's like you have no real way of knowing if you're gonna get like an A- or a B+ in a class. Like, you don't know that close. You don't really know until like the last day. My uni was the same. The honors starts at 3.5, 3.0 when it has COVID. Yeah. What's up, Robert? You can drop a course after a final. Yeah, at some of these schools. I feel like you're a nerd but a jock at the same time. LOL. You play any sports? Yeah, I play tennis and hockey. But hockey, I don't know jock. Jock is kind of like a what do they call that? I don't even know, but it's kind of like derogative. So I wouldn't claim myself to be a jock, but I used to play sports like full time. Like that was my career path before I got injured. I played hockey. I played ice hockey at a hockey university, at a hockey academy, and I was planning on going to university for hockey after playing juniors. You ever thought of trying BJJ? Don't know what that is. Should I Google it? Am I gonna get banned for Googling it? Sounds a little... Oh, Brazilian Jiu-Jitsu. No, I did not think of trying Brazilian Jiu-Jitsu. Yeah, no. I wouldn't want to play... I mean, now that I'm a full-time student, I don't want to play any sports that could severely injure me again. Because when I got injured, even though I am probably going to play hockey next semester, but I don't know. It's in the man's name, LOL. Yeah, it is. That's crazy. I don't really want to play any sports where I could get any brain injuries, because that would severely set me back, at least in my plan, because I'm trying to take so many classes and do this really quickly. I'm trying to graduate early and stuff. Graduate really early, and then graduate from my master's early as well. So, yeah, I don't know. I wanted to go to the ice arena, but this kid said he can't go. What's the goal after that? I want to continue learning after that. Are you doing a PhD as well? Yes, I am. Oh my gosh, guys. Okay, let's see what you have to say. Wait, assuming your first freshman class was this past fall, it was. Good assumption. When did you want to get your undergrad and master's by? I want to get my undergrad and master's both within 4 years of my first class. So 2027. I want to have both degrees by 2027. I can graduate from my bachelor's degree I can graduate from my bachelor's degree 3 semesters early, but I think I'm only going to graduate 2 semesters early because I don't know. I just want to I want to take it a little bit easier than graduating 3 semesters early. Bro is Dr. Vegapunk. I don't know who that is. How and when did you learn Python? It's railing me right now. Python? I mean, these are always such weird questions because I'm a computer scientist. I'm not a coder. So, well, I guess I can code, but when I use programming languages, I use programming languages to articulate problems that I solve myself. Like I'm just writing algorithms that I already know in my head. I just need to translate them into Python or C++ or whatever so the computer can understand what my brain is thinking. So I never really had to learn Python necessarily. But I would say you can use LeetCode. LeetCode's a pretty good way to learn how to solve problems and stuff and then translate that into programming languages. What does graduate early mean? Do you take whatever courses whenever? Are they nationalized? If you were really interested in math, how much would you be able to do at undergrad? So you need 128 credit hours to graduate from my school. and each major will have its own individual requirements. So my major requires me, here, I can just show you. I mean, I have a lot of, so I have my whole graduation plan here for my bachelor's degree at least. So like this has all my classes and these are all my requirements that I have to meet. So like right now it's at 122, but obviously I can get to 128 pretty easily. But like I have to take these are my degree requirements. I have to take my math and science classes, my physics classes, and then my more physics classes, and then free electives I can take whatever I want, and then a whole bunch of gen eds, which I think gen eds are really stupid. But yeah, I have to take gen eds. So like for me, most of my classes are like CS and physics classes, as you can see, and then like early on in my undergrad, like I have to take math, all these math classes as well. Math 221, 231, 241, 285, 257, I forgot about that. CS 173 is also a math class. So how many credits you have right now? I took 19 last semester, 3 over winter break, so 21 or 22, and then I took 18 my first semester, so around 40. I think I'm at 40, maybe more than 40 in 2 semesters. So at that pace, I can graduate in what, 6 semesters? Yeah, 6 semesters, and that's exactly what I'm gonna try to graduate in. Oh, and then the summer. Oh crap, I forgot about the summer. I'm taking 11 credit hours this summer, so by the time my sophomore year starts, I'll be at 51 credits. I think the craziest bit are the gen eds for sure. You are 19, 20, 21. What's the point? The last time I did any of that was 16. Yeah, exactly. I think that's a good thing to say. But like, if you wanted a math degree from UIUC, let's just look up undergrad. Because you were asking about, oh yeah, there it was, degree requirements. You're asking about math. It depends on what type of math. Let's just do a pure math major. Pure math. You just take, look, like this is just a bunch of math classes. Oh wait, this is a minor, I think. Oh no, this is a bachelor's of science. Yeah, but that's not from my school, so I don't know what they have to do. It's like a different college. It's from a different college. I'm not in that college, so I don't know what their requirements are. Each college has its own requirements. You minored in cybersecurity. So real gen eds are annoying, like earned credits. Yeah, earned credits, I'm at 40 earned credits. Oh my bad, saw I said class, thought it was course. Course and class are the same thing. Are you telling me that a physics major won't benefit from gen ed classes like mysticism and mysteries? Yeah, exactly. Did you enter the college with AP and DE credits? If yes, how many? I entered college with 0 credits. I had 0 credits coming into college. Cybersecurity talks about, oh yeah. I feel like it's a good skill. Cybersecurity, I think that's what you're talking about. You got scholarships covering your accelerated venture for that degree. That is a lot of money, not gonna lie, especially credit hours are inflated during the summer. So at my university, you pay your tuition, and that allows you to take up to 18 credit hours per semester. So I really don't go that much over. It might be like $150 extra a semester, so it's really not that big of a deal. But I'm planning on getting scholarships. You might feel overwhelmed, and my master's and PhD will both be paid for. You might feel overwhelmed. I do not feel overwhelmed. Not me particularly. You're talking to someone else. If you're talking to someone, I suggest that you at them so that other people don't get confused. Oh, okay, I'll have a look, thanks. What were your high school states? I think you meant stats. How do you manage so many credits per semester? I study. It's really not that difficult. What's your GPA? I had a 3.94 as of last semester. Thank you for insight. Yeah. So you can also pick up credits in high school. Yeah, you can. I didn't. I came in. Oh yeah, I know. I didn't. I came in with 0 credit hours. So, but I know kids that came in with like 70 plus credit hours. So they were already halfway done with graduation by the time that they entered university. Wait, how can you guarantee your PhD studies will be covered? I can't guarantee it, but the only way I would do a PhD is if I got a scholarship. I want to be a Rhodes Scholar, so that's what I'm applying for, and they fully fund your PhD. But I wouldn't do PhD if it wasn't paid for. My master's is guaranteed paid for by my university, and that's through a program that I've already talked to them about that. So my master's will for sure be 100% paid for. And if I did a PhD through my university as well, I could get it fully funded, but I don't think I would want to get a PhD from my school. It's just too much time spent on campus. It'd be kind of crazy. I'd be like the most dedicated student. I would be there for like 10 years in the same school. You're thinking of doing the PhD online? No, I do not like online classes. Yeah, you are lucky that uni is free in your country. That's sick. Super senior, bro. I'd be like a super duper senior. I'd be there for like 12 years. Scandinavian, yes. Oh, you're Scandinavian. I don't want to do my PhD at UIUC. I would do like a bunch of other things, like my master's and my bachelor's at UIUC, but not PhD. The only 3 PhD programs I'm probably going to end up applying to are MIT, UC Berkeley, and the Rhodes Scholar for Oxford. Community college is a great option. Community college is great. It's way cheaper than normal school. Unless you can get a scholarship for normal school. I had teammates, 2 of my teammates from last year were from Sweden. It's pretty cool. Yeah, who knows? Maybe in 4 years I won't want a PhD. So we'll see. We'll see where that road takes me. A community college is a 2-year institution opposed to a university, which is 4 years. So a community college, you cannot earn a bachelor's degree or a master's degree or a PhD. You can only earn an associate's degree, which is just 1 level down from a bachelor's degree. Usually though, it's typical for people who go to community college to later transfer to like an official university so that they can achieve a bachelor's degree. And in that way it's cheaper because you can take the same courses that you would have to at university at community college, but community college is far cheaper than university. So the main benefits of community college are monetary and maybe time. If you want to go to school what you want to pursue doesn't require you to go to school for 4 years, rather like 2 years. I like how community colleges are smaller classes and a lot of professors focus on teaching than research. Yeah, that's great. At my school, yeah, professors definitely are there for the research, for sure. How many hours do you study a day and what days of the week? I study Monday through Friday, and it depends day to day. Are you a research assistant right now at Aiden Andrews? I am not. I'm a freshman, so it's not really many opportunities, but I also didn't try to become a research assistant kind of just wanted to focus on myself freshman year. So I'm doing research by myself, and I plan on publishing a research paper at the end of the summer. But yeah. So I'm not a research assistant. However, I am doing research. I've never even heard anyone associate an acceptance rate with community college, because generally community college is automatic admission. What? Think so. Generally, community college is that's another main reason people go to community college, is because there's automatic admittance. Sorry. By yourself, how does that work? I did not know you could do that. Don't you need an accredited institution? Yeah, I go to an accredited institution, so I can just use them. What are you eating? I'm eating a Jimmy John's sandwich. It's my second one today. For publishing your work, ain't no way. Yeah, for sure you can publish your work through your university. But I was just planning on publishing it on my own website because it's a personal research project. I'm just doing it to learn. I don't need the world to know my name. I don't really care. Yeah. But you can still publish it through your university. Look. Look, you can publish. You can just publish your work. I probably could still publish to one of those. I don't know what that is. But no, I'm just publishing it on my website, and then I'm probably gonna put it on GitHub and Averix. Good night, Vaprium. Favorite programming language? C++ is my favorite programming language. I would agree with that. It's a lot of, for people, it's the weed out class. I don't study discrete math anymore. I'm finished with it. This is a textbook. They wrote it, the University of Illinois wrote it. I think. I honestly don't know who wrote it. Why did you choose UIUC? I only applied to two schools, so I didn't really have much of a choice, but it's a great institution for what I want to do. It's ranked top 5 in computer science and 9th in physics in the United States. So. Harvard. Is Iowa State a good school? I think so. I haven't really looked at it. We can look together. Looks like it's pretty good for engineering. Iowa State's good for engineering. Number 2 in biological engineering. They're ranked above my school in biological engineering. 58, it's top 100 in public schools. I think we're like 12th or something. Yeah, we're 12th. Why didn't you apply to others? I had no need to. I was planning on being an athlete first of all, so that's the main reason I didn't apply to many schools. But after I got injured, I still found no need to apply to more schools. Yeah. I mean, if I didn't get into either, I could have just gone to University of Iowa, which is like down the street from my house. And yeah, that's essentially automatic admittance. Yeah. Yeah. No, I don't play video games at all, to any capacity. I used to. Okay, what are we saying? I used to play video games, yeah, back in the day when I dropped a 20 bomb on Fortnite. But no, now these days, I haven't even. Yeah, no, I definitely don't play video games at all anymore. Any opinions on University of Maryland? I don't know. I don't know. I'm not familiar. I can tell you watch anime. Yeah, I do. I watch tons of anime. I was muted. But I'm watching Solo Leveling and Monster right now. This is my full list of animes. I think I might be missing a couple on the list, but I don't really care. Okay. Do you read Japanese picture books? I don't. It's funny, you were here last stream. When you first started the channel, what were your goals? Is it something to look back on? Or is it to hold yourself responsible? It was to hold myself responsible. That was the main reason I started. But now I like it because of I get to talk to a lot of smart people throughout the day that I would not have been able to talk to regardless, like if I didn't. The Discord's pretty fire, so that's why I do it now. It's never gonna be monetary. If you ever catch me doing anything for monetary reasons, you can comment and remind me to stick to my roots. And the sole reason I started it was just I just wanted the video because like I would study for hours and hours and hours, and I was like, there's no proof of me studying, so I just did it for like proof. I was like, okay, here's proof. Like here's proof for myself, and like and to hold myself responsible, because it's a lot harder to do bullshit when you're on camera, you know. I can't scroll on Instagram Reels when I'm on camera. I was watching YouTube and I didn't want to get copyrighted, so that's why I was smiling. You just saw my channel and you recommended? Yeah, I know. YouTube algorithm's crazy, dude. This damn machine learning's getting out of control. It's 5:11 though. I don't know why I'm talking about that. Talking like that. It's 5:11 though, so I might low-key end her here. I might honestly end this stream soon. Maybe like 20 more minutes or something. Sitting down with Neuralink's first brain chip implant patient. It's crazy. Yo, you wanna see? I'm getting a new center console, Tyler, in my car. You know, someone said in the chat, in Discord, they said, whoever said this Matchbox bot, may God bless you. The tunes he plays are only bangers. It's soothing and chill. Yeah, that is exactly the video that it is. That's right. I'm 14. What? Vaprium? Yo, he might be in chat. Vaprium's 14. Ghost Rider's 23. Hold on, let me answer on my other Discord account. Sorry, I was just texting the Discord. Are you Christian at Aiden Andrews? No. Yeah, I wouldn't think so. Maybe I am. I don't know. It's hard. I wouldn't say I would declare a denomination though. I don't know. What? Huh? What are your parents? My parents are Christian. Yeah. I haven't done enough research on the religions to know which one I'm most aligned with. Well, I do live my life very strictly, so I imagine I follow most religions. Pretty much all. I pretty much don't sin like ever. No matter what piece of holy text you want to use to establish your list of sins, I would say I probably don't sin in any of them. And I believe in God, but...
Amen.
You talking to me?
What did you just say?
Nothing. Where's that sweatshirt? You have it on?
No, it's right there.
No, it's right there. Yeah, I need to take a picture of it. I'll take a picture of it right now. I need to post something so that people know Neverone isn't dead. No, I haven't posted on that account in like years.
Not years, bro.
What?
Not years.
Well, obviously not years. It hasn't even existed for years. Is it wet?
Maybe my shirt was wet.
It smells like roses.
Thanks.
Okay, bro. You're actually so weird. They're hiding in a basement? Yeah, I think so. What are your thoughts on the current beef between Kendrick and Drake? I'm not really familiar. I have no input because I don't know. I'm impartial. Bro, you know I haven't posted in a long time because Instagram isn't even installed on my business phone anymore. What have I been doing, bro? Should I even post it on Never Alone? Should I just post on my own personal Instagram? Yeah, I should. I'll just post on my story. It's gonna get more attention on my Instagram story anyways. That beef is over now? Yeah, bro, I can't keep up. This bullshit's getting out of hand. Can't keep up with all of it. Oh crap. Alright, I'll be right back. me check M40i. Oh yeah. This makes no sense. We'll use as little words as possible.
Huh?
Clear filters, dude. Okay. Make BMW model 440. Year 2019. Yeah, these are going for how many miles?
52.
Yeah, there's one on here for 32,000 miles for $35,000.
Yeah, so 30
Well, yeah, and your engine is way better than this engine. Well,
technically,
your exhaust is better. You have carbon fiber.
Oh, I forgot I had
Tints. People pay for all that stuff. CarPlay.
Yeah, I forgot how that thing like the exhaust. It does have full screen CarPlay too.
Yeah. Why are these girls so loud? What should I do for ejercicio? ¿Qué hacer para ejercicio? No sé, no sé. Un momento, por favor. Mi teléfono. No answer. No bueno. Paradise. Para. Should I do Shopify?
Talking to me?
I'm talking to myself.
Shopify for what?
I was for Never Alone, and I need to fix some of your stuff, so. Easy Drone CR.
Yeah, the weather's ass today, so.
What?
So the weather's ass.
Yeah, the
today,
weather's
so I'm
ass,
gonna
yeah.
get today. I had 2 jobs already, like kind of not on the schedule though.
Trade me, and I know that you never feel. Let me just quit everything on this computer, bro. Remind me later, bro.
Hey, what do you think would happen if look, You see how he's trying to beat on me? What would you think would happen if I flick his balls like this?
Do it. I was flicking them yesterday. Whoa, pause.
He'd probably die. Bro, what is this group chat, bro? You're in this group chat. They're talking about sailors or something. Bree saying sorry to all the sailors I'm taking.
I don't know.
You got a weird ass thing, like.
I don't know. They're always talking about some weird shit in there, bro. That's in Cousins?
No, this is Uncle Kevin and shit.
Oh.
Look at it. I turned off notifications, but I just looked at it.
I did too. Bro, it's...
Turn off notifications for all of them.
What do they think this is? I can't be like looking at text messages all day. Yeah, it's bad.
Bro, I'm about to go to Chris. Fucking do this.
Bro, come on. Alright, bro. Wait, does Control-Alt-T not pull up a new window? No, it doesn't. Gosh. What? Watching this while getting a fade? Yo, that's crazy. Betrayed me, and I know that you'll never feel sorry. You talk to her, man. Bro, what is going on? Control-Alt-Shift. Control-Alt-Shift. Wait, what? Why is my keyboard not working? Is it on Mac? Is that why? I need a fucking... It is, it's on Mac OS, that's why. I was wondering why none of my commands were working. Let's close this.
Ooh. Ew, Tyler, catch girl.
Wow.
You always need me. With me, I'm loving from the start until you. Hold on, guys. Oh wait, actually, let's just do this. Hold on. I can't leak my Shopify numbers, bro. Oh, I'm not leaving. Bro, what the fuck is this? Dude, I don't know what.
on Sunday? Yo.
Yeah, I'll be back on Sunday.
Okay, yeah. They asked if we want to run at Court 45.
For sure, it's gonna be there.
You know, Tristan, all them guys.
Oh, yeah, that'll work.
Yeah, Sunday. At, I think 7 p.m.
Okay, sounds good.
Where you at?
What does that make
I'm
the?
headed to Missouri, come back tomorrow.
You're in Columbia?
Yeah, come back tomorrow, so, yeah.
Alright, boy, I'll let you get back to
I
your
have to do this
activities.
one.
Alright, bro, sounds good.
Alright.
Wait, is Patrick and all of that? And Colin and all of them?
I was working out with Patrick, but nah, he left. He went to Butler.
So who's gonna be there on Sunday then? Just besides Tristan?
I don't know, but I know it's gonna
Oh
be
yeah,
good.
what's
It's gonna be
that?
better
What's
than
that
just
about?
fucking going on the wire or some shit, bro.
Yeah, that's true. Alright, that sounds good. See you, man.
Alright, boy. Peace. I take a shit.
I can use it as a separate display. It's not working anyways.
Dude, all these random girls keep following me.
Upstairs. Where you left it? Yes, upstairs. What?
Not even like I did a post or anything. You know.
When are we gonna drop, guys? I don't know. Drop June 2024. Well, I'll need to take product pictures, right? -4 in stock. Yo, does our inventory look good? Guys, does our inventory look good? Drake T. Archived. Let's just do only active products. Cause
I don't know.
whoa, what was that? Loading speed is poor. Why? Didn't know GPT could do what? GPT's not done anything on either of these websites. that's what I was gonna do. I don't know where it is though. It's in the footer. No, not JSON. But this is a JSON file. Hello? Bro, next. There it is.
This nigga Jack is scared.
Scared of what? Where do I go now? Gosh, Shopify is so slow. Oh, typography. Oh, here we go. Okay, let's find all caps font. Abolition, I heard, is a good all capitals font. They don't have that. Bro, what is your cat doing?
If he falls or hurts himself, it's on him.
Yeah, you should start with the math first.
And into the light, late night.
Yeah, where's style? Oh, theme. My God, it is so slow. Okay, it works. All uppercase now. It's over. I'm ending stream. I won't be back till Monday, so see you guys later. Have a good day, everybody. Monday, join the Discord.